Hello everyone. Again we have a question based on the magnetic moment of the coordination complexes, and the question says the correct pair among the following in which each species shows orbital contribution to its magnetic moment is. So we have different complexes in their different oxidation state of the central metal ion, and we are asked to identify which pair of these complexes show an orbital contribution to its magnetic moment. So we know that when does a complex show orbital contribution means for coordination complexes, mostly we have the spin only magnetic moment. Okay, but the total or effective magnetic moment is the summation of mu orbital, the orbital contribution to the magnetic moment plus the spin contribution. So mu orbital plus mu spin is the total magnetic moment of the coordination complexes. Now, when we have this orbital contribution, then one of the factors when this orbital contribution is added to the total magnetic moment is when the T2G orbital is unsymmetrically filled in the octahedral complexes or T2 orbitals in the tetrahedral complexes. So based on this knowledge, we will solve this problem. Okay, so the first pair of complexes, let us identify COCl4 2 minus and nickel H2O 2 plus. Okay, so cobalt is the central metal ion, and we know that the valence electronic configuration in the ground state is 3d7 4s2, and here we have 4 chloroligands. So the oxidation state of cobalt in this complex is plus 2. Cl has a minus 1 charge. Okay, so in the plus 2 oxidation state, the valence electronic configuration becomes 3d7 4s0. And now there are 4 ligands in this cobalt complex. That means this is tetrahedral. Okay, so we have to arrange these 7d electrons in the tetrahedral geometry. Okay, so we have 7 1 2, and also Cl is a weak field ligand, so there will be no pairing initially. So high spin complex, so 1 2 3 4 5, and then pairing will start 6 and 7. So we have 4 electrons in E and 3 electrons in T2. Now if you see carefully, these T2 orbitals are symmetrically filled, means the electrons are evenly distributed in the T2 orbitals, and that is why there will be no orbital contribution. So no mu orbital contribution for this complex. Then moving on to the second complex, nickel H2O whole 6 2 plus. So nickel, as you can see, is plus 2 charged here because H2O ligand has a 0 charge. And in the plus 2 oxidation state, nickel is 3d8 4s0. And there are 6 aqua or water ligands. So it is an octahedral complex with a D8 configuration. And we have H2O, which is a weak field ligand. So again, there will be high spin condition. So initially, singly occupied 1, 2, 3, 4, 5, 6, 7 and 8. Now, T2G is again fully filled, completely filled. It has 3 orbitals and 6 electrons, and that is why T2G for this nickel complex is also symmetrically filled, and that is why there will not be any mu orbital contribution. Okay, so no mu orbital contribution. So our option 1 is not the correct answer. Then moving on to the option 2, NiCl4 2 minus. So we have the second option, NiCl4 2 minus. Nickel is plus 2 charged in the plus 2 oxidation state because Cl has a minus 1 charge, and also chlorine is a weak field ligand, and that will give rise to high spin complexes with unpaired electrons first, and then the pairing will take place. And nickel in the plus 2 oxidation state has 3d8 4s0. Now we fill these electrons in E and T2, the 8 electrons. So 1, 2, 3, 4, 5, 6, 7 and 8. Now you can see this T2 orbital is unsymmetrically filled because we have 3 orbitals and 4 electrons. So uneven filling of T2 orbitals, and that is why this contributes to mu orbital. So this option we have mu orbital contribution towards the effective magnetic moment. Okay. Now moving on to the cobalt complex, COF6 2 minus. So cobalt, here you can see the oxidation state of cobalt. If we take it as X and we have 6 fluoroligands, minus 1 charge for fluoroligands, and minus 1 into 6 is minus 6, and the total charge on the complex is minus 2. So X becomes plus 4. So cobalt is plus 4 oxidized. So it's a very high oxidation state of cobalt, and we have the fluoroligand, which is otherwise a weak field ligand. But this is a special case where, due to the high oxidation state of cobalt, this weak field fluoroligands acts as a strong field ligand. Or in other words, you can also say that because of this very high oxidation state of cobalt, the complexes are the low spin. So low spin complex is formed due to the high oxidation state of cobalt. That means pairing of the d electrons will be favored. Okay, so now cobalt in the plus 4 oxidation state. So in the ground state, cobalt has a valence electronic configuration of 3d7 4s2. So in the plus 4 oxidation state, the valence electronic configuration becomes 3d5 4s0. So 2 electrons from S and 2 electrons from D are gone to give a d5 configuration, 3d5. Now since we know that this complex is a low spin complex, so pairing will be favored. So 1, 2, 3, and then pairing starts in the T2G orbital itself. So 1, 2, 3, 4, 5. So 5 electrons in the T2G orbital. Since 5 electrons in the T2G orbital, what does that mean? It means the T2G orbital is unsymmetrically filled. And because of this unsymmetrical filling of T2G orbital, there will be mu orbital contribution towards the effective magnetic moment. So that means in option 2, we have NiCl4 2 minus and COF6 2 minus, where the T2 and T2G orbitals are unsymmetrically filled, okay, which contributes to a mu orbital contribution towards the effective magnetic moment. So option 2, both the complexes have mu orbital contribution towards the effective magnetic moment. So option 2 should be our correct answer for this question. And I will conclude here because we have got our correct answer, but I will request each of you to go through these options 3 and 4, which have cobalt, chromium, nickel and another chromium complex. There are 4 complexes in option 3 and 4. Please go through all of them and try to find out whether the T2G orbital or the T2 orbital, in case of tetrahedral complexes, whether they are unsymmetrically filled or not, and whether they will contribute to a mu orbital towards the effective magnetic moment. So if you do these options 3 and 4 also to check whether there are any complexes which are contributing towards mu orbital, then that will be a good practice for you. So I request all of you to go through options 3 and 4 as well. So I have shown you the steps. I have shown you how to do it. You have to just identify the central metal ion oxidation state and fill the electrons in the T2G and EG or E and T2 orbitals depending on the geometry, and then you have to check whether the T2 or T2G orbitals are unsymmetrically filled or not. Then you will get your answer. So I hope this explanation was clear enough. If my videos are helpful to you, please like, share and subscribe, and please let me know what you want to learn next in chemistry in the comment section. Thank you so much.